Today we'll be looking at the sine law and cosine law. To begin looking at our sine law, an oblique triangle is a triangle that does not have a right angle. We cannot use the primary trigonometric ratios with these triangles. So if there is no right angle, you can't use your sine, cosine, or tangent trig ratios. So SOHCAHTOA will not work. So what we're going to be using is our sine law and our cosine law. So first we're going to examine our sine law. So in a sine law, for any oblique triangle, you can use this. So it is given to you in two different forms, where you have sine A over A is equal to sine B over B, which is equal to sine C over C, or you would have the flip where you have A over sine A equals B over sine B, which is equal to C over sine C. Now, what I say, general rule of thumb, is if you have an unknown angle, use the one where you have your sine A and sine B and sine C in your numerator. If you have an unknown side, use where you have A, B, and C in the numerator. Now notice also, when we're labeling an angle, angle A, for instance, we have sine A. We will use an uppercase A to show that. And the side, which is opposite, for instance, angle A is side A, but we represent a side with a lowercase letter. So we will be using both ways of figuring out with the sine law. Also to note here, you're never going to actually have all three fractions equal to one another. You only deal with two at a time. So let's go ahead and look at some examples here. So example 1, we want to find the length of the indicated side to the nearest meter. So that indicated side we have is side P. So using my sine law, what I do notice is I have my corresponding angle, which is 39 degrees here. And then the other side that I have is 15 meters. The corresponding angle to that is angle S, which I don't know what the degree measurement of that angle is. However, I do know that any triangle will add up to 180 degrees. So angle S I can find by taking 180 minus 39 minus 61. So what I will get is 80 degrees. So now I have two sets of angles and their corresponding sides, and I can use the sine law. So I'm going to use P in my numerator, since that is my unknown, over sine P, which is sine 39, which is equal to our 15 over sine 80. What I'm going to do next is I'm actually just going to cross multiply. However, I'm only going to bring that sine 39 up here because I want to isolate P. I want P by itself. So what I'm going to do next is I'll have P equals 15 times sine 39 all over sine 80. So now you can plug this into your calculator. Alright, make sure that you do use brackets, and it all depends on your personal calculator of how many brackets you need. So when I plug that in, I'm going to get that P is equal to 10 meters, since I want to round to my nearest meter. And that will be example 1. So now let's look at example 2. In example 2, we want to find the measure of the indicated angle to the nearest degree. So it's hard to see here, but your indicated angle is angle O. So let's look. I have I know I want to find angle O. I have its corresponding side, which is 20 centimeters. And then I have another angle here, which is angle M, which is 79 degrees, and I have its corresponding side. So I have enough information already to go ahead and use our sine law. So since in this case I'm trying to find my angle, I'm going to have my sine O in my numerator all over 20, which is equal to sine 79 all over 34. And once again, I'm going to bring that 20 up. I'm going to cross multiply. However, I want to isolate my O, so I'm not going to bring that 34 up and multiply it. So when I bring that up, what I'm going to have is sine O is equal to 20 sine 79 divided by 34. So sine O will be equal to 0.5774. Now recall, how do I find my angle O? Well, we do the inverse of our trig function. So the inverse of sine is 0.5774. And what we'll get is that our angle measurement will be 35 degrees. Again, make sure you read the question because it tells me in the question to the nearest degree. So now let's look at our third example here for our sine law. A field is in the shape of a triangle. Label the triangle ABC. So let's do that first. So we have a triangle here. Let's label it ABC. A surveyor determines that the length of side AB, so the side here from A to B, is 620 meters. Using a theodolite, the surveyor finds that angle A is 56.8 degrees. So I can label angle A as 56.8 degrees and angle B to be 60.4 degrees. We want to find the perimeter of the field to the nearest meter. So remember, perimeter is just going to be equal to A plus B plus C, right? We just add up all of our sides together. So now what we need to do is we need to figure out our missing sides. So what I notice here is that I have a couple angles, 56.8, but I don't have its corresponding side. And I have 60.4, and I as well don't have its corresponding side. So that corresponding side will be B, and the corresponding side to angle A is A. Now, one thing that I do have is side C, but I don't have angle C. So how do I find angle C? Well, since we know the interior angles of a triangle add up to 180, I'm going to take 180 minus 56.8 minus 60.4, and what I'm going to get for my angle C is 62.8 degrees. So now I have one of my ratios here, and now we can go ahead and solve for A and B. So let's first solve for A. So I'm going to have A over sine 56.8, which is equal to 620 over sine 62.8. And that is all because of my angle C and my side C. Now we're going to cross multiply here. Again, remember, we want to isolate A. So we're going to cross multiply, but we're not actually going to bring that sine 62.8 over to the left side. We're just going to bring the sine 56.8 to the right side. So what I have is A equals 620 sine 56.8 all over sine 62.8. When I do that calculation, I'm going to get that A is equal to 583 meters. So now we're going to do similar thing, however we're going to find side B. So we have B over sine 60.4 is equal to our 620, because it's side C, sine 62.8 since it's angle C. Once again, we're going to cross multiply, isolate B, so we're only going to bring that sine 60.4 over to the right side. So we have 620 times sine 60.4 all over sine 62.8. And what I will get there is 606 meters. So now we need to find our perimeter, add our three sides together, so 620 plus 583 plus 606, and we'll get a total of 1,809 meters. So therefore the perimeter is 1,809 meters. So now let's look at our cosine law. So our cosine law, once again, is using the same type of triangle as we would have in a question that we would use the sine law. However, the problem is our sine law is used when we have either two measures of two sides and a contained angle, or you have three measures of three sides. So if you have the measures of two sides and a contained angle, highlight it here, it would be, say, side A and C, and your contained angle would be B. Now if you had your three sides, obviously we would know it would just be that you have A, B, and C. So when this happens and you don't have enough angle measurements to be able to use our sine law, what we use is our cosine law. So our cosine law is stated as A squared equals B squared plus C squared minus 2BC times cos A. One thing I want you guys to note, make sure that you keep the 2BC cos A together. Don't separate it at all. It is one term. Now our other two cases here, these two cases, they are the exact same as our first equation here for our cosine law. It's just rearranged using our side B with our, sorry, this should have been cos B and this should have been cos C. And so it all depends what you're given and what you need to find for how to set up your cosine law. Do notice that we have side A and angle A. You have side B and angle B, and side C and angle C. So make sure when you're setting it up that you do set up the formula correctly. So we're going to go straight ahead and look at an example here. We want to find the missing side length to the nearest tenth of a unit. Now what you see is we have side R and side P, and we have angle Q. So since I have angle Q, I know I want to find side Q, so I'm going to set my equation up as Q squared is equal to our P squared plus R squared minus 2PR cos Q. So now let's sub in for all of our known values. So I don't know q, so it's q squared is equal to our p squared, so 11.2 squared, plus our r squared, minus 2 times 11.2 times 8.6 cos, and our q is 57 degrees. So now we can just do some calculations here. So 11.2 is 125.44 when it's squared, plus 8.6 squared is 73.96, minus, now with your calculator here, some people might feel more comfortable first doing your cos 57 and then multiplying it by your three other terms here, or you can just put it all in at once, however you feel most comfortable with. So when I put those values in, I get 104.919. So q squared, when we add and subtract everything on our right hand side of our equation, we get 94.481. Now to find our q, we're going to square both sides, and we're going to get that q is equal to 9.7 meters. Notice in this case, we do have a decimal since the question says to the nearest tenth of a unit. So our next example, it tells us that we have triangle KLM. So let's first draw out a triangle. It may not be to scale, but that's okay as long as you label it. So we have KLM. It tells us that side K is 54.2 centimeters. So we know that this side here is 54.2 centimeters. Side L is 45.7 centimeters. And side M is 36.9 centimeters. And what we're trying to solve for is angle K. So since I'm trying to solve for angle K, I'm going to have it set up as K squared equals L squared plus M squared minus 2LM cos K. So now what I'm going to do is sub in for all my known values. So I have 54.2 squared is equal to my L squared, which is 45.7 squared, plus my M squared, which is 36.9 squared, minus 2 times our L, 45.7, times our M, 36.9, cos K. So now what I'm going to do, I'm going to square each of my values here. So I have 2,937.64 is equal to 2,088.49 plus 1,361.61 minus 3,372.66 cos K. So now I can collect all of my like terms. So what you can do is you can add this up and then move it over to our left hand side. Because one thing to remember, this is one term. You can't subtract the 3,372.66 from our other terms because it has a cos K. It's not a like term. Please don't mess that up. So what I'm going to have here is 2,337.64 minus 3,450 50.1 is equal to negative 3372.66 cos k. When I subtract these on my left hand side, I get negative 512.46 is equal to negative 3372.66 cos k. Now I divide both sides by negative 3372.66. So I'll have that cos k, because these cancel out, and when we divide this is 0.1519. So cos k is equal to 0.1519. Remember, to find k, I need to do the inverse of cos of 0.1519, and I'm going to get that k is equal to 81.3 degrees. Again, make sure that you read the question. It tells me here, let's find k to the nearest tenth. Now for our last example here, we have two boats left the dock at the same time. One traveled at 7 kilometers per hour on a bearing of 39 degrees. The other traveled at 5 kilometers per hour on a bearing of 82 degrees. How far apart were the two boats after 1 hour? So one thing that I want you to note, that a bearing is measured from the north clockwise. So we could just write that down. So bearings are measured from the north clockwise. So let's start by drawing our diagram. So what we have our dock where two boats are leaving. So we're talking about it leaving, okay, and a bearing is measured from your north. So the first boat leaves on a bearing of 39 degrees. So that's this angle here. So we measure it clockwise, so it's 39 degrees. Now, if we look at our second boat leaves, but it leaves on a larger bearing of 82 degrees. So this here, whole angle is 82 degrees. So what we need to do is we need to find this inside angle here between the two boats. So to find that, you're going to take 82 minus 39, which will give you 43 degrees. Also, another thing that the question tells us is that the first boat leaves and it's traveling at 7 kilometers per hour, and the second boat is traveling at 5 kilometers per hour. So we need to look at 3 hours. So I'm going to redraw my triangle here. I have my dock. I'm going to have my boat 1, and I'm going to have my boat 2. I know my angle measurement here is 43 degrees, and in 3 hours, how far will boat 1 have traveled? So I take 7 and multiply it by 3, which will give me 21 kilometers. Similar to boat number 2, multiply 5 by 3, and what we get is 15 kilometers. And what the question is asking us is how far apart were the two boats after 3 hours? So we need to find the distance between boat 1 and 2. So you notice here we have side, angle, side. So one of the characteristics of when we can use our cosine law. So we have d squared will be equal to 21 squared plus 15 squared minus 2 times 21 times 15 cos 43. Again, remember, this side d is the corresponding side to our angle 43. So what I'll have is d squared is equal to 441 plus 225 minus 460.75. So d squared will be equal to 205.25. Then we can take the square root of both sides. So we have d is equal to 14.3 kilometers. So therefore, after 3 hours, the boats are 14.3 kilometers apart.